Hello everyone, I am Abhishek and today I am going to present one of the IEEE Communication Service tutorials paper, survey and tutorials paper. The title of the paper is Digital Twin Technology for Intelligence Vehicle and Transportation System, a survey on applications, challenges and the future direction. And it is submitted to the research method course midterm exam, and the instructor of this course is Dr. Isan Ali. So as we all know that autonomous vehicle and ITS system are very uh, demanding field for its safety and efficiency benefit, but there are still some challenges and issues such as real-time monitoring, predictive analytics, decision making, and so on. So by using implementing the digital twin, we can optimize it. So what is digital twin? Digital twin is a replica of physical layer, which includes all the vehicles and the surrounding infrastructure, and it allows us to real-time monitoring and control capability. So there is a great impact on this area. So it is about in 2023, transportation is the fast growing segment of global digital market at approximately 15%, emphasizing that the relevance of the digital twin for ITS. So here is the difference between the digital twin and traditional system. So the first difference is the data flow. For traditional system, it is one way. That means we collected the data through the sensors, and for the future analysis we store it. But for the digital twin, it is two-way, which allow real-time synchronization as well as the control. For example, if any car's engine is hot, then we send the then it send the data to the digital twin, and we can control it by turn on the cooler car cooler. So the second one is the functionality. For traditional system, it is passive monitoring and report. For digital twin, it is predictive simulation, close loop optimization. For example, if any roads have possibility to get a traffic conjunction in the next 5 minutes, then we can capture it by DT by analysis, and we can control it by increasing the signal times. The third one is the integration. For the traditional system, it is fragmented and follow the subsystem. For example, every bus company might have their own system for routing gas infrastructure of their vehicles and so on, but they are not shareable. But for the digital twin, all the vehicles and the infrastructure are connected with each other, so we can do the analysis. So it is unified. That's why it is called unified cross domain model with the live updates. The fourth one is the decision, which is human centric for the traditional, and proactive, autonomous, and machine driven for the digital twin. Use cases are historical analytics, fault logs, and for the digital twin, it is predictive maintenance and dynamic optimization. So here is the DT architecture. So we can say that in digital twin there are three main layers. The first one is the physical layer, which has all the assets such as sensors or other data collection devices. The second layer is the communication layer, which is responsible for data transmission to the server or database. There are multiple techniques that are allowed, that are discussing this paper. Then the third layer is the digital layer, which is for the data preprocessing and AI model analytics. So here we can see that they highlights the other survey study before the study. The research gap of that they found that are most of the studies are domain specific, such as they only talk about the maintenance or smart city or DT security or IoT advancement, or circular network. The second research gap is the most of the studies are theoretical and they do not focus on the ITS and or CAV in a comprehensive way. No practical information provided and no case study are discussed. So no single survey systematically covered the DT's role in CAFs and ITS ecosystem, which is the research gap for them, and they cover it in this paper. So the main contribution of this my paper is they provide a comprehensive study of DT applications such as safety, traffic, etc. Beside the theoretical literature, they also provide the case study and the practical knowledge. They also discuss about the enabled technologies of DT, discuss about the possible solutions on different uh, advanced topics such as is cloud partitioning, hybrid AI models, and resilient networks. And then they conclude the last contribution is the future direction, so that the other researchers can see their work and do research on the research gap. So it is the structure of the survey paper. In the first section, they talk about the background motivation and structure of the paper. In the second section, they talk about the enabling technologies for digital twin that already used in previous studies, and then they categorize it. In the third section, they talk about the digital twins for vehicle safety. In this section, they discuss about the challenges, the potential of the digital twin for safety. Then they highlight the applications. Uh, Same structure follow in the next two sections for traffic management and the intelligence and autonomous vehicle for digital twin. The research opportunities are discussed in the section 6, and in the section 7 they conclude it with the conclusion. This is a screenshot of categories of enabled technologies and tools for digital twin. They identify it by previous study, previous study, and then they categorize it. It illustrates that which tools or technology is used for data related techniques or physical related techniques or model related techniques or connection related techniques or service related techniques, such as for data collection which sensors are already used, or which platform is used for data storage, or for connection what are the interfaces and protocol already used. So here is the strength of the paper that I found. The first one is the wide-ranging coverage, which actually says that the paper is very detailed and updated the DT foundations as well as the they talk about the DT enabled techniques, applications in safety, in traffic, applications in autonomous vehicles. The second one is that they provide the practical examples as well as they talk about the case studies, and they also talk about the theoretical one. The paper is very well organized and they uh, provide many figures so that a reader can learn about the important topics easily. So the limitation of this paper is they do not provide the any experimental data or quantitative benchmark of the DD system, and also there is a scope gap. That one is the such as the human factors or policy challenges, and they do not talk about the economical benefits of this digital twin. So one of the future direction that they're talking about, that one is connectivity and sensing. They talk about the 5G and 6G networks. So in 5G and 6G network, it is very low latency, so that the sensors can send the data through the communication layer without any interruptions. The multi-sensor fusion is about different IoT devices can be combined for better accuracy. They give the future directions of that. Then they talk about also the then they also talk about the edge computing. Then they talk about the future direction of AI or ML. They talk about the AI driven DTs like reinforcement learning, federated learning, how they can help, how they discuss how it help in the digital twin. Then they talk about the explainable AI that is not implemented yet. Like explainable AI is very promising technologies which actually describe why this decision is making. Currently in AI and ML, we do not know why a particular decision is coming. Then they talk about the is AI like V2X and the other things. Uh, then in the future direction of security and privacy, they talk about the secure V2X protocols, anomaly detections, resilient architecture, privacy preserving DTs. So in the conclusion, we can say that the paper is very well structured and it discuss about the all the enable techniques and categorize it. Also, they talk about the advanced topic. They uh, give the practical knowledge besides the uh, theoretical knowledge, and but there is a lackings of open data sources and practical knowledge, uh, so that we cannot easily regenerate it. So in the future directions, they talk about in four different uh, topics, and it is very well detailed. So thank you everyone for watching it.